we're going to work out the velocity of the moon around the Earth. All right, so we know that the moon has a period, as it says here, it takes 27.322 days for the moon to orbit the Earth. And the moon is on average a distance of 384,400 kilometers. That is the distance from the Earth, from the center of the Earth to the center of the moon. All right, so we're going to use that number. Now the distance that the moon is traveling is really the circumference of the circle, right? So since we know the radius of the circle, the circumference is 2 pi times the radius. So we'll just multiply 2 pi times this distance here. All right. The other problem that we have is we know the period. The period of the moon is given to us as 27.322 days. But with that in mind, you have to convert days to since it asks us right here very clearly, how fast is the moon traveling around the Earth in kilometers per second? All right. So we'll get the kilometers here from the distance between the center of the Earth and the center of the moon, and then multiplying that by 2 pi. So the units will still be kilometers, but the period is in days. So we need to do a conversion. All right. So we always do these conversions, whether any of the sciences, by the way. You just need to know the conversion factor. All right. And so we all know the conversion factor between, for example, how many hours are there in a day, right? I mean, some conversion factors you have to look up, like, that there's 2.45 centimeters in an inch, stuff like that. Like those kind of things you look up, or, that would be given to you. All right. So anyhow, this one, everybody knows, of course, so I have days right here, right there. There's days, and so what I do is in the denominator I have to put 1 day is 24 hours. All right. So now we're going to continue to convert this so that now the days cancel. Units cancel just like numbers. All right. So I know that in 1 hour, so I guess I used a capital H, there are, of course, 60 minutes. And here, when I write minutes, notice I'm writing MIN. We always reserve lowercase m for meters. So in minutes, just write MIN or something like that to distinguish it from meters. All right, so we know that in 1 minute, again, MIN, there, of course, are 60 seconds. All right, so now the minutes cancel, the hours cancel. And so if I multiply the period of the moon, which is 27.322 days, that's very precise, times 24 hours, times 60 minutes, times 60 seconds, I will have converted this many days, 27.322 days, to seconds. All right, so let's go ahead and do that. Here, I've got a calculator right here. See if you can. Yes, you can see that. All right, so this is my calculator. All right, so I'm going to go 27.322. All right, and then times 24, and then times. So times 60 times 60 is simply times 60 squared. All right, so that just squared the 60. All right, so it's more than 2 million seconds. All right, so we don't we can write that number down here. I'll do that right here. So it's 2360. I gotta remember this. All right, because as soon as I touch the screen here, that it'll disappear. All right, I'll make it appear again. So 2 million. 3, I'll put a comma, 360, comma. All right, so this is, I want to be precise here. So where's my calculator again? All right, there it is. 62.8 620.8. Okay, so 620.8. All right, and that's seconds. Right, that's an 8. All right, so we have the period now in seconds, right? It's right, right here. This is the period in seconds, and so all we really have to do is we just take the circumference, which is going to be our distance, right? So it's the velocity. I didn't write this down, of course, but the velocity is just going to be the distance divided by the time. The distance divided by the time. But in our case, right, because this thing is going, this is the moon going all around the way around our world in a more or less circular orbit. It's not exactly circular, but we always approximate it to be circular. Only like the ones that are very, very elliptical are things like comets. The planets travel almost in a circle. All right. Anyhow, so this is going to be 2 pi times. Now we already know this the distance. So it says the radius, but it's a radius in terms of the distance from the center of the circle being the center of the Earth. So it's 384,400 kilometers. All right, so we're gonna multiply that, and then we'll divide that by our period. All right, so here we go. Let me get my calculator again. Actually, I'm going to okay, I don't really want to retype that number, so I'm going to store it. All right, so there it is, the 2 million. Here, let me just show you that if I hit memory recall, see that's. So when I'm about to do that in just a moment. All right, so let's get this. Let me move this over. Let's get we'll get the distance. So it's going to be 2 times pi times 384,400. Right, so that's the distance that it travels. Right, if you know the radius, the circumference is 2 pi times the radius. All right, so this is the circumference. All right, so there it is, and then we're going to divide by this number of seconds. Over 2 million seconds. And notice this answer is right around 2 million. And then we say divided by, and so if I hit this memory recall, there it is. All right, and so that is that is the calculation. That's the circumference of the the distance that the moon travels in its orbit around the Earth, and divided by the period in seconds. This in kilometers, this would be 1.023. We could just round it to 3 places past the decimal. All right, so our velocity here, I'll rewrite it down here. Our velocity turns out to be, in kilometers per second, it's going to be 1.023 kilometers per second. Kilometers per second. All right, very nice. Okay, so this is a 2. Sorry, that doesn't look like a 2. Yeah, and like if we were to let me just do something right here just to show. I did ask, right here, what was the answer in kilometers per second. Let's say we figured that out, and then there was a part B. I mean, there's not here, but if there was, and in part B it said convert it to meters per second. Well, you even though you have a velocity here, you can convert the kilometers to meters. All right. So here's what you do. Again, it's the same kind of thing. So notice I have kilometers in the numerator, so I'm going to have to put 1 kilometer in the denominator. But 1 kilometer turns out to be 1,000 meters. All right. So that's the kilometer parts cancel. I mean, it's really important to be able to do this. The kilometers part cancels, and so you multiply by 1,000. Let me get my cursor. Here it is. You multiply by 1,000, and so you see all that does, of course, is it moves the decimal place, 3 places to the right. All right. So in meters per second. All right. So we've already done it in kilometers per second. So I'm just redoing this in meters per second, because sometimes you want to be able to convert. Um, Sometimes it's nice to have it in meters per second. So it would be approximately 1,023 meters per second. All right, so that's some very nice, a nice little conversion for us. Um, that's just a good way to do these kind of things. Um, all right, so just to review real quickly, we know the distance between the center of the Earth and the center of the Moon. It's approximately this value. This, by the way, it's about 250,000 miles. So in kilometers, that's about 384,400 kilometers. Um, and then, of course, you realize that the path that it's actually taking is the circumference, which is, of course, the distance, right? This is the distance, right? This amount, this 2 pi times r, this part is the distance, and that's what we did up here, right? That's exactly what we did right there. And then actually, how I started it off was turning the period of 27.322 days. We didn't really need to know it that accurately, but it's usually if somebody were to ask me how long does it take the moon to go around the Earth, it's 27.3 days. All right, so roughly, right? This is more exact. All right. So anyhow, you say in one day there's 24 hours, right? I mean, you always have to cancel the units. Always think about canceling the units, right? Um, and so people often ask, okay, well, how do I know the 24 hours doesn't go down in the denominator? See, the hours won't cancel, right? The only thing that'll cancel here is days, and so you have to have the days in the denominator and the 24 hours in the numerator. And the same thing goes with the next conversion. Okay? Remember, these are conversions. 1 hour is 60 minutes. 1 minute is 60 seconds. So you just take this number 27.3, right? 22 times 24 times 60 times 60 again, and you get this number here. A little more than 2,360,000 seconds, right? So that this is exactly what it is. And then you take that distance that you calculate, the circumference that it travels, and divide it by that time, and you get the answer in kilometers per second. So it turns out to be a little more than 1 kilometer per second. That's how fast the moon is moving. And then I decided to convert it, just because sometimes we want the answer in meters per second. And of course, that requires you to know that in 1 kilometer, there are 1,000 meters. Right? So the kilometer part cancels and just says, hey, multiply this number by 1,000, and then you'll be in meters. And of course, that's just moving the decimal 3 places to the right. All right. So what else? What else do I have to say about this one? One of the things that people often notice is the period here. The time it takes the moon to go around the Earth is 27.3 days. However, the period of the phases of the moon, the phases are 29.5 days. Why is there a difference? So shouldn't they be the same? But the thing is, the reason is the Earth has moved a little bit in its orbit around the sun, and so for the phases to catch back up, you know,